What if I told you that a plane declared dead could rise again? The Airbus A380, that gentle giant with an 80-meter wingspan, stopped production in 2021 after an estimated $25 billion in development costs that were never recouped, delivering only 251 aircraft. Most experts wrote its obituary, but Emirates has a different plan. They're advocating for something that sounds impossible. Airbus spending an estimated $15 to $20 billion to resurrect the world's largest passenger jet with radical improvements. The question isn't whether this sounds crazy, it's whether crazy might actually work. Why did the most ambitious aircraft project in history become aviation's biggest commercial failure? The A380 was supposed to be the future. When it first took flight, this double-decked marvel promised to carry 853 passengers at once, more than any aircraft in history. With its 575-ton maximum takeoff weight, it generated thrust equivalent to 2,500 family cars. The numbers were staggering: 550 square meters of passenger deck space, a 7.1-meter fuselage diameter, and 280,000 pounds of total thrust. But here's what went wrong. That massive 80-meter wingspan limited airport compatibility. While 220 airports could accommodate A380 operations for scheduled and alternate use, most required operational workarounds rather than full infrastructure compliance. The four engines consumed approximately 11 to 12 tons of fuel per hour, with the aircraft requiring 85,472 gallons of total fuel capacity compared to 52,300 gallons for modern competitors like the 777X. Operating costs hit $26,000 to $29,000 per flight hour. The aviation industry was shifting beneath the A380's massive wings. Airlines discovered that passengers preferred direct flights over connecting through massive hubs. Point-to-point operations became the norm, and modern twin-engine jets proved they could fly virtually anywhere through extended twin-engine operations, or ETOPS, regulations. Advanced aircraft like the A350 can operate up to 370 minutes from diversion airports, while most twin-engine aircraft achieve ETOPS 180 certification, requiring in-flight shutdown rates better than 1 in 100,000 hours. The A380 used only 25% composite materials, while newer aircraft like the Boeing 787-9 achieve 50% composite construction. The Airbus A350-1000 delivered 53% composite materials and burned just 32 pounds of fuel per nautical mile, compared to the 777-9's 48 pounds. The A350 family achieved an 18% fuel efficiency advantage, burning 0.09 pounds per seat per nautical mile versus 0.11 pounds for its competitors. So why would anyone want to resurrect this fuel-hungry airport-limited giant? The answer lies with one airline that refused to give up. Remember that $20 billion resurrection plan? It's not coming from Airbus, it's coming from Emirates. Sir Tim Clark, Emirates president, made a declaration that stunned the aviation world. If you build them, we'll buy them. This wasn't just talk. Emirates operates 116 A380s, more than all other airlines combined, controlling the majority of the active A380 fleet worldwide. But Emirates isn't asking for the same aircraft. They want what industry analysts call the A380neo, a completely reimagined version that would address every critical flaw of the original. While specific technical details remain conceptual, Clark has discussed the potential for breakthrough technologies that didn't exist when the original A380 was designed. The proposed improvements center on three key areas: advanced composite construction that could achieve 50+% carbon fiber reinforced polymer content, doubling the composite material usage of the original design for dramatically reduced weight and improved fuel efficiency, folding wingtips inspired by Boeing's 777X development to improve airport compatibility, and next-generation engines. But the real transformation lies in what would power this reimagined giant. The heart of Emirates' A380neo concept beats with technology that represents a complete evolution in aviation engineering. The centerpiece is the Rolls-Royce UltraFan engine, a marvel of modern engineering with a 140-inch fan diameter. This geared turbofan architecture delivers 25% improved fuel efficiency over first-generation Trent engines, while generating between 25,000 to 110,000 pounds of thrust. The engine features composite blades, heat-resistant materials that can withstand extreme temperatures, and 100% compatibility with sustainable aviation fuel. Think about what that means. A 4-engine aircraft that could theoretically achieve the fuel efficiency of modern twin-engine jets, while maintaining the passenger capacity advantage that made the A380 so special. The UltraFan isn't just theoretical. Rolls-Royce has been testing it extensively. This engine technology represents the kind of breakthrough that could address the A380's fundamental weakness, fuel consumption. But engines are just part of the equation. The A380neo would incorporate the same advanced materials transforming modern aviation. The Boeing 787 proved that 50% composite construction delivers massive weight savings and improved fatigue resistance. The A350 family demonstrated that 53% composite materials can achieve superior fuel efficiency. The technology exists to fix the A380's problems, but does the market still want what it offers? Here's something the industry's efficiency obsession overlooks: passenger experience. The A380 offers over 550 cubic meters of cabin volume, space that no other aircraft can match. Emirates leveraged this space to create experiences impossible on smaller aircraft. Onboard shower spas, full lounges, and wider seats across all classes. These aren't gimmicks, they're revenue generators that command premium pricing. The A380's massive interior allows for amenities that create customer loyalty and justify higher ticket prices. In an industry where passenger experience increasingly differentiates airlines, the A380neo could offer something no competitor can match: space. But can passenger experience justify the massive investment when the industry has moved toward efficiency? The answer might lie in a problem the aviation industry hasn't solved. Airport slot constraints create a unique economic environment where bigger might actually be better. Heathrow operates at 42 to 44 movements per runway per hour with severe slot limitations. Emirates runs 6 daily A380 flights there, demonstrating how slot scarcity can justify large aircraft economics despite operational challenges. According to airport operations data, Heathrow serves multiple A380 destinations, though exact daily departure figures vary seasonally. Other slot-constrained airports like JFK and Narita face similar capacity limitations that create niches for high-capacity aircraft. Environmental pressure adds another dimension. The International Civil Aviation Organization has set carbon-neutral growth targets for 2050. While the original A380 was an environmental disaster per seat, the A380neo concept could potentially deliver competitive emissions performance. Sustainable aviation fuel production is scaling up 70-fold by 2050. And the UltraFan engine's 100% SAF compatibility means the A380neo could operate with up to 94% reduced greenhouse gas emissions compared to conventional jet fuel. The aviation industry projects continued growth in air travel demand. But here's the critical insight. While 90% of long-haul flights connect major cities suited for point-to-point operations, that remaining 10% represents hundreds of routes between the world's largest airports, where capacity constraints create demand for very large aircraft. The market conditions exist. The technology is ready. So why hasn't Airbus announced the A380neo program? Would you commit $15 to $20 billion to revive a project that already lost an estimated $25 billion? That's the question Airbus faces with any potential A380neo program. According to industry estimates, such a project would require completely rebuilding the supply chain that was dismantled when production ended. The assembly lines are gone. The specialized workforce has moved to other projects. Regulatory certification for new engines, folding wingtip systems, and increased composite construction would require extensive testing and validation. The Boeing 777X offers a cautionary tale. Certification delays have pushed its entry into service to 2026, 6 years behind schedule. Technical issues, including uncommanded pitch events and engine thrust link cracks, demonstrate the complexity of certifying advanced aircraft systems. Even if Emirates commits to buying 50 or 100 aircraft, Airbus would need multiple launch customers to justify the investment. The original A380 required over 420 aircraft sales to break even. The Neo version would face similar mathematics. The concentrated customer base presents another risk. Emirates controls 61.3% of current A380 operations. Building an entire program around one airline's vision, no matter how compelling, represents enormous commercial risk. The A380neo represents more than an aircraft revival. It embodies the tension between efficiency and experience, between proven market trends and visionary leadership. Emirates has the operational expertise, financial resources, and strategic vision to make this work. The technology exists to address the original A380's fundamental flaws. Market conditions at slot-constrained airports create economic niches where very large aircraft make sense. Environmental pressures could favor aircraft that maximize passenger throughput while minimizing flight frequency. But success requires Airbus to bet billions on a concept that challenges everything the industry has learned about aircraft economics over the past 2 decades. The Wright brothers were told human flight was impossible. The Boeing 747 was called a white elephant that would bankrupt airlines. Sometimes the aviation industry's biggest breakthroughs come from ideas that initially seem impossible. So here's my question for you. In an industry obsessed with efficiency, does visionary leadership and passenger experience still matter enough to justify bringing back the gentle giant? Let me know in the comments. Would you fly on an A380neo?